Welcome to SMILEQ, qNMR with Jason. My name's Ian Day, I'm from JEOL UK, and in this presentation I'm going to tell you about SMILEQ, which is our plugin for our Jason software, which allows you to do qNMR analyses within Jason. In this talk I'm going to give you an overview of Jason, show you some of the key features, just explain a little bit about what the software can do, talk a little bit about plugin architecture within Jason, how we enable more advanced analyses to be performed, and how we give users the tools that they need to do their work. And then for the remainder of the presentation, I'm going to focus on SMILEQ, which is our plugin for doing quantitative NMR analyses. I'll talk a little bit about the key principles behind qNMR. Hopefully this is something that's that everybody already knows. However, it's useful just to reiterate a few points. I'll then demonstrate how SMILEQ can be used to do internal standard qNMR measurements, how it can be used to do external qNMR measurements when we're using external standards, what corrections we have available within Jason, and I'll talk a little bit about multi-spectrum SMILEQ, how you can analyze multiple samples, replicates of samples, and how you can get the analyses performed easily within SMILEQ. So Jason is NMR processing software from JEOL. Jason is designed for all of your post-acquisition data processing needs. On this slide you can see an overview of some of the key features that we have within Jason, and we have all the tools that you would expect to find in a modern NMR processing package. So tools such as peak picking, integration, multiplet analysis, we can do all of those sort of techniques within Jason, either in a manual mode or in a fully automated manner. We have tools for producing reports, drawing your structures, drawing your molecules, being able to view molecules in 3 dimensions, charts and fitting for various analyses that you might want to do. All of those tools are within Jason. One thing that's key to point out is that Jason is vendor agnostic. We support data from all of the major high field vendors and the benchtop vendors. So it doesn't matter where your data comes from. Once your data is within Jason, all of the tools work in a broadly similar way. We can do the same analyses on any sample that you have within Jason. More advanced features are handled via plugins. These are additional pieces of software that live within Jason that allow you to do more advanced analyses. I'll talk a little bit more about them a bit later on, but the focus of this presentation is going to be on SMILEQ, which is our qNMR plugin. Now, I mentioned that Jason is vendor agnostic. So this is a slide just to show you that in practice. Here I've got 5 data sets from 5 different vendors, 5 different sorts of experiments, and I've loaded those data into Jason, and you can see that they all look broadly similar. The representation of the data is the same regardless of which NMR vendor the data comes from. What you can see in the middle of each spectrum is a watermark. This allows you to easily identify the type of experiment that you have and the type of data that you have. We have a fairly sophisticated experiment recognition algorithm within Jason that looks at the raw data that comes in and analyzes things such as the name of the pulse sequence, the nuclei that are set up in the experiment, how the data has been acquired, etc., to provide that watermark. So it allows you to easily navigate over the spectra that you have loaded in your canvas. You'll also notice on the bottom right here we have structure. This is structure drawn within Jason, and we can also load mol files and SDF files into Jason. Now you'll notice on this structure there are some numbers at the atom positions. These are predicted chemical shifts. Chemical shift prediction is one of the tools that's available to you as standard within Jason. Before I get too far into explaining about the qNMR side of Jason, I just wanted to spend a minute talking about the licensing behind JSON. JSON is a subscription model software. A lot of software these days is subscription based. JSON is no different. The benefits for you as a user are that you get frequent software updates. We provide updates to JSON every 3 months, so you get new features are available every 3 months, and we release a bug fix version every month. So having the subscription means that you're always up to date, you've always got access to the latest features, and you always have access to a fixed version of JSON. From our point of view, it means it's easier to support our users. Our users are always available, always up to date with their software. Now, the pricing of JSON is designed to be around consumables level. The base cost for JSON itself is relatively inexpensive, and we do have discounts available for large user bases and campus licenses. Now, I mentioned at the beginning of this presentation about the plugin architecture within JSON. So JSON's core functionality is designed to be suitable for the vast majority of users. So the average chemist in the laboratory will be able to take JSON with their NMR data and be able to analyze their compound and get the information out that they want. It's designed to be affordable and easy to use. But we're aware that there are lots of tools that specialists might want to use. More advanced analyses, more focused on particular applications. And this is where the plugins come in. The idea here is that we can effectively package the functionality within a plugin, and it means that if you don't need those particular tools, you never need to worry about them. If you do need those tools, you activate your plugin and more tools become available to you. And currently we have 3 plugins available for JSON. One is our MagRes plugin. This is designed for solid state NMR spectroscopists who are doing NMR crystallography. And this is a plugin that's designed to read output that comes from DFT calculations, particularly plane wave DFT calculations from packages such as CASTEP and Quantum Espresso. MagRes can read those files, view the data within JSON, and allow you to do the comparison with your experimental data. We have a file filter plugin for Simpson that allows us to read the output of Simpson files. You can get those data directly into JSON. And we have SMILEQ, which is our plugin for doing quantitative NMR analysis. And that's what I'm going to talk about for the rest of this presentation. What I also will say is that we have a number of other plugins that are currently under development, so keep an eye out on our website for information about those as they become available. One thing I will note is that plugins typically will require an additional license, and that might be something to consider. Okay, so I'm going to spend the rest of the presentation now talking about SMILEQ. So like all good NMR spectroscopists, we have to have an acronym. So SMILEQ is the Spectral Management Interface Launching Engine for qNMR. Basically, all this means is that we've packaged all of the tools that you need to analyze your qNMR data into the plugin, and once you activate the plugin, it allows you to perform these analyses. So SMILEQ has the tools that you need to be able to do the qNMR analysis. So we can do analysis by internal standard, the traditional qNMR approach, and calculate purity, concentration, etc. We have a number of automated analyses built in so that you're able to generate reports quickly. We can analyze multiple data sets. So if you're doing replicates or repetitions of a particular series of experiments, SMILEQ can handle all of those sets of data, all of those analyses. We can generate reports, so all the information that you need downstream, so what information has been calculated, what were the parameters in the experiment, etc. And if you have a JEOL NMR spectrometer, then we have a complete measurement to report pipeline. This allows you to put the sample into the spectrometer, set a few options on the spectrometer acquisition software, submit your sample, and then at the output is a PDF generated by SMILEQ. Okay, so just to give you a little bit of an introduction into qNMR, where it comes from, just review a couple of concepts before we get into looking at the analyses that we can do within JSON. So we all know that NMR is an inherently quantitative technique. It's one of the few analytical techniques that we have where we don't need calibration curves. The response, the detector response in NMR is directly proportional to the number of spins that give rise to that signal. And it's a completely linear relationship. If we double the amount of sample, we double the size of the signal in absolute terms that we get back. And we're all familiar with the concept that the integral of a signal is proportional to the number of spins that produce that signal. And we use this idea all the time, particularly relative intensities between signals in our NMR spectrum. We use this all the time when we're doing structure determination, for example. So in the example I have here, we have our molecule, ethyl-indinone. If we look in the aliphatic region, we can see signals with integral of 1 each, and another signal with integral of 3, and I can use that information to immediately know this is my methyl group here on my molecule. So we're using this quantitative information that's present in our NMR spectra all the time. And we all know that this works for mixtures too. If we have a mixture of two compounds in our NMR tube, then the integrals between those two compounds relate to the relative concentration of those two compounds, obviously correcting for different numbers of nuclei and things like that. But this idea is the basis of all qNMR experiments. And that's what we're going to use over the next few slides to do our qNMR analyses within JSON. So again, here's an example. This is a synthetic spectrum just showing you two signals. Here we have two signals A and B, and they have relative integrals of 2 to 1. So the concentrations, we can relate the concentrations of the two signals to each other based on the ratio of their intensities and the number of nuclei that are involved in each signal. So for example, if we know if signal A was our compound of interest and signal B was our reference material that we've weighed out precisely and we've made up our sample precisely, if we know the concentration of B, then just by comparing the integrals and the number of protons for those two sites, we can then calculate the concentration of A. And this is effectively how all qNMR experiments work. Our reference material can be, is typically some sort of certified reference or some sort of standard material that we've made up depending on the nature of the analysis that we want to do, or it could be an artificial signal such as in the uretic experiment or something like that. So from this approach we can calculate the concentration of our analyte based on the concentration of our standard, the number of nuclei present at each site, and the signal intensities. And again, we don't need a calibration curve for qNMR because our responses are linear. We can also, if we know the amount of material that we use to make up our sample, we can also use qNMR to work out the purity of analytes, or we can use it for determining potency in the pharmaceutical industry, for example. How much of a sample is actually API compared to excipient, that sort of thing. And SMILEQ performs all of these calculations for you based on the information that it gets from your data. Okay, so SMILEQ has three basic main modes of operation. We can set up an internal standard experiment, we can set up an external standard experiment, or we can do multi-spectrum, a multi-spectrum approach. And the multi-spectrum approach can be either internal standard or external standard. So in the internal standard experiment, we have our reference compound in the same NMR tube as our analyte. In the external standard method, we run one sample of our standard, and then in a separate tube under the same conditions, we run our analyte of interest. And also, it's worth pointing out, we have a tool, qNMR Seamless, which I've already mentioned, which allows you, if you're running a JEOL spectrometer, to automatically generate all of these reports when you submit the sample to the spectrometer. You can have JSON running on your host computer. You just tick a couple of boxes within our acquisition software, and then when the acquisition is complete, Delta, the acquisition software, will hand over the data to JSON, and JSON will do the appropriate analysis. So what I'm going to do now is just give you some examples of these three particular modes of operation. So we'll start with an internal standard measurement. So here we have the SMILEQ panel. So this is where all the information related to our quantitative experiment is undertaken. We have a drop-down menu at the top, which allows us to set the analysis mode for this particular sample. So this is where we set whether we're doing an internal standard experiment or whether we're doing an external standard experiment, and whether this particular spectrum corresponds to the reference compound or the analyte. What this effectively does is set up the panel to give you the boxes that you need to put the information in. So we start off with information on our analyte. So we have our sample name, molar mass, sample volume. And we can set SMILEQ up to get this information automatically from our experimental data, if possible. So if you have these values set as parameters when you submit your experiment, we can pull those from the experimental data automatically. Otherwise, you can populate this form manually. We have a box for the reference information. So this is where you set the reference compound. And we have a library where you can store information about your reference compounds. And in here you store, for example, the batch of your reference compound, how many protons that signal corresponds to, where that signal is located, etc. And again, we can specify the amount of material, the amount of reference material that's been used. And again, this can be pulled automatically from the experimental parameters, or you can fill it in manually. We then have a target signal table. So this is a table that gets generated when you undertake an analysis of your spectrum, either manually or automatically. So either you can set integral ranges on your spectrum manually, or you can use automatic integration, and that will generate this target signal table. And then all we do is select which signals we wish to be part of our qNMR analysis, and then we can press the update button, and that would go and do the calculation for us. You can see here at the bottom in this quantitative results section, we have the purity and the molarity specified for our particular sample. So this is how we set up the experiment. What do the results look like? This is what we have for the results. So this is a typical report that we would get from SMILEQ. So we have our NMR spectrum. You can see that integrals and multiplets have been analysed on this spectrum. We have our internal standard. So this is a sample of butyl paraben with DSS as our internal standard. So we have an integral set for that. We have a table here which gives us our results multiplet by multiplet across our spectrum. So we have the position of the multiplet, its start and finish positions, the sum integration, so that's adding up a point by point integral across our spectrum, a deconvoluted peak area. So if you prefer to use a deconvoluted peak approach, that's possible as well. A column that represents the number of nuclei that correspond to that signal, and then the purity and the molarity calculated for that particular multiplet. And then on the right, we have an analysis results table. And here we have some information about what the analyte was, what the reference was, where the reference peak was, how the calculations were performed, and what the answers are. what the final result is. So we have an average purity, and this average purity is the average of these purities here. We have standard deviation, and we have an RSD quoted as well. And so this is the sort of report that you would get out of doing the SMILEQ analysis. And as I said, we can generate all of this automatically, or you can go through all the steps required to do this manually. Moving on now to the external standard measurements. We have a similar looking panel. This time we're now set to external standard. This is the example of the analyte spectrum. So there's no reference information entered here. We just have information on our analyte and some other information. So in the external standard method, you have one sample that contains your analyte and one sample that contains your reference compound. And the idea is that you run your reference compound, and then using that spectrum and using information from it and the fact that the NMR spectrometer gives a standard response when you put your analyte in, we can then use that information to work out the purity. So, as before, we have the information on our analyte, and again, we can pull that from the experimental spectrum if it's available. We have a box where we set which spectrum contain, or multiple spectra contain, our reference information. And so we can either have a single reference spectrum, or we can have multiple reference spectra. If you've got replicates of your reference spectrum, that can be done as well. We have information on the corrections that can be applied. So there are a number of schemes published where you can correct for differences in experimental parameters between the data that was used for the reference compound compared to the data that was used for the analyte. So the PULCON method allows you to correct for things like differences in sample temperature, differences in pulse width, differences in receiver gain. And so we can turn on or off any of those corrections if you wish. More recently, we've introduced a correction called SOLCOR. This is a solvent correction, and this is to allow you to compensate for differences in the sample volume between NMR tubes. So although NMR tubes are all high precision pieces of glass, there are subtle variations in, for example, tube diameter, wall thickness, that might mean that one tube has half a microliter larger volume in the active air in the coil than another tube. Now, as long as your reference and analyte are recorded using the same batch of deuterated solvent, then we can use the residual solvent signal as a proxy for the sample volume. And this checkbox here, this allows you, if you have a solvent signal defined in your spectrum, to apply that correction to the calculations. So you can correct for differences in sample volume. We then have our target signal table, which tells which multiplets we're going to include in our calculation. So for example, here you can see that this multiplet is unchecked, so this one wouldn't be included in our calculation. And then we have our results as before. So showing you this in JSON, this is the output that we have. So we have our analyte spectrum. In this case, this is acetaminophen, and we have our reference spectrum, which again is DSS. So we have our reference signal here, and in our analyte spectrum, we tell SMILEQ to use spectrum number 2 as the reference spectrum. And then when we do the calculation, we get the same output as we had before, a multiplet by multiplet analysis and an overall summary report. So regardless of whether you're doing internal or external standard calculations, JSON can give you the output in the same format. JSON is also able to analyze multiple spectra at the same time. So this could be, for example, if you're doing replicate work. So for example, you might want to make up 5 or 6 samples, say, and do qNMR across all of those samples to see what variation there is caused by, for example, the person making up the samples. SMILEQ has a multi-spectrum mode where you can load a number of different data sets. So in this case, we've got 3 replicates of our butyl paraben example. This is an internal standard experiment. And so JSON is able to run the analyses, and it runs an individual analyses for each data set. And then it generates a summary report for both the purity and the concentration of all of those samples. And so we can get all of that information. And we can look at averages across the samples or averages within the samples and see how the reported purity and the reported concentration varies for our particular sample. So this allows you, as I say, to analyze multiple data sets, do replicate analysis. We have the summary reports available, and very recently we've introduced the ability to do uncertainty budget calculations according to ISO 24582. So this allows you to provide good statistical information about your analyses. Okay, so I just wanted to finish off by reiterating a few of the key messages around JSON and SMILEQ. So JSON is our post-acquisition NMR processing software that's designed to be easy to use for non-experts, but have powerful features available to satisfy expert users. So if you just want to use JSON to determine your structure, that's very straightforward. If you want to use it to process the latest non-uniformly sampled pure shift experiment, you can do that as well. We're vendor agnostic, so we don't care where the data comes from. High field data, benchtop data, it's all the same once it's within JSON. And we have a number of tools to analyze, to automate key tasks and provide access to your data for downstream applications. I haven't talked about that in this presentation, but those tools are available. We have regular updates. So as I mentioned, JSON has feature updates that are released every 3 months, and bug fixes that are released every month. And we're driven by customer feedback. So if you try JSON out, if you use JSON, please tell us what works, what doesn't work, and let us know. Okay, so just to summarize, particularly with regard to qNMR, SMILEQ is our spectral management interface launching engine for qNMR. It's our plugin that allows you to do qNMR analyses simply and straightforwardly within JSON. We have tools that allow you to do internal standard, external standard experiments, purity and concentration, or purity and or concentration, automated analyses, the analysis of multiple data sets, generate reports, and provide automatic quantitative NMR analyses. And as I mentioned, we have a complete measurement to report generating solution for JEOL NMR systems. So thank you for listening to this presentation. If you have any queries, please feel free to get in contact with us, support@jeoljason.com, and we'd be more than happy to talk to you about your qNMR workflow and how JSON could fit within that process. Thank you for listening.